Hi, my name is Bahubali Shetty, and welcome to this ElasticON presentation. I'm going to be talking to you about how you can achieve observability independence with OpenTelemetry. So let's just start off by thinking a little bit about how we sort of live our lives today. Now, whether it's personal or business, it's all driven by software and applications. And to make things worse, we're sort of at a point where we kind of want everything yesterday and almost immediately, right? And we want our apps to be resilient, always on. God forbid something actually goes down. We want it to be always on and even, well, geographically available. So wherever we go around the world, around the country, everything's got to be working. Now, this creates an enormous set of requirements on developers and the operational staff or SREs. Think about what would happen if an app didn't work. Better yet, what happens if the internet goes down? Well, let's not think about what happens if the internet goes down. But when an app does go down and it's not responding, whether it's business or personal, it sort of throws off your routine, throws off the processes, and it can cause business implications. Now, a majority of those interactions with an application are essentially what we would call digital transactions. And this is an important concept to understand. So, what is a digital transaction? Well, let's take a look at a typical rideshare application that almost everybody uses today, right? There's a point in time where you ask your application for, hey, I want a ride to work. You get the driver, and the car comes, picks you up, takes you to work, drops you off, and you get charged. That end-to-end flow is a digital transaction. Now, it's actually broken down into several bits and parts. And that entire transaction is what's called a trace from end to end. The subcomponents are smaller parts of that trace are called spans. So let's say you select your application, you say, I would like a ride to work. It then goes and finds a driver, the driver accepts, and those are like 2 to 3 steps that occur in finding a ride. You get in the car, you get to work, but during that, you're checking status, you're checking updates. The driver is actually indicating what's happening. When you get to work, it's another set of steps that are occurring. The system actually goes and authorizes your credit card, makes the payment, and the driver says he's delivered you, right? So all these sort of little interactions are parts of the trace and are spans in the trace, but the end-to-end component is that transaction or the trace itself. And all the bits in here, the latencies, the metrics around all these components are very important to collect. And how do you collect this data? Well, the most common mechanism today is called OpenTelemetry. And OpenTelemetry, some of you may or may not be familiar with it, but it's fairly popular, so I'm assuming most of you are. Let's just start with what it is, right? It's a CNCF project, and you can take a look at the OpenTelemetry.io website where it basically defines it as follows. It's a collection of tools, APIs, SDKs, which are used to instrument, generate, collect, and export your telemetry data, your metrics, logs, and traces to help analyze your software's performance and behavior. Okay, what does all that mean? Well, simply put, the OpenTelemetry project provides you with several things. And if I can simplify this, it provides you with a set of APIs and SDKs that you can instrument your application. Now, there's 2 types of instrumentation, and I'll talk about that in a minute, manual and automatic. It defines a standard protocol, OTLP, and a standard schema of sending data, right, whether it's metrics, logs, or traces, to an endpoint of your choosing. You can do that in 2 options. You can actually send it directly from an application itself, where you've instrumented it and put the endpoint information, or you can aggregate it through a collector and send that through. And remember, one of the benefits of this is that that OTLP protocol provides you a standard schema for metrics, logs, and traces. And this is mainly why a lot of organizations, and probably a lot of you on this presentation and this talk, are using or will be using OpenTelemetry. Now, it's mostly used and pretty much it's 90% plus. It's mainly for your application. Now, there are some parts of the project that are looking at Kubernetes and Amazon and your cloud bits, but 90+% to 100% of all installations of this are application microservice-based. And there's other parts that are in progress. Now, you get to choose that endpoint. And we will talk about it today, is how Elastic is an ideal endpoint for you, right? And hopefully you choose Elastic, but you can choose other options like Jaeger or Zipkin and other components that provide you with UIs. Now, they're great for small projects, but they may be hard to scale across your organization. So let's talk a little bit about the instrumentation options and how you can instrument this. Now, as I mentioned, there's two main instrumentation options, right? There's automatic and manual. Now, automatic instrumentation, the name says it all. There's no need to instrument the code. However, while it's less code because you're not changing your code, each language does have a different method to implement automatic instrumentation. Here's a simple example. Say in Python, you add a library, an auto instrumentation library, into your environment. You actually install it, and then you run your Python as normal. And the automatic instrumentation library will dynamically rewrite the methods and classes at runtime and add the necessary bits. All you have to do is then specify the endpoint location and the extra where you want to send your traces, i.e. Elastic. However, the one negative here is that not all languages support auto instrumentation. You have Java, Python, and Ruby, and I think .NET right now. Some of this may change. Check out the OpenTelemetry website for the latest. Manual instrumentation is as it says. You have to get into your code, add the libraries manually, and it takes a bit of work. However, the advantage here is that you get to determine what you want to measure, and you get to control how much information gets sent out. There's advantages and disadvantages on either one. So I personally like manual instrumentation because it gives you that granularity and control. However, if you're just testing components out and want to play with something very fast, auto instrumentation will work if you are using one of those languages. Let's just quickly review where OpenTelemetry is in traces, metrics, and logs. Now, with traces, this is probably the most GA or stable set of libraries, right, in OpenTelemetry. All your popular languages, Python, Go, Java, JavaScript, etc., are all supported and in stable state. And it's fairly simple to implement. Now, as a quick little example here from the hipster shop, specifically the recommendation service, which is written in Python, and it's the OpenTelemetry demo, which you can find on the OpenTelemetry website GitHub page. And it's very simple, right? You add your libraries from OpenTelemetry. In this case, we're importing trace. Then you initialize the tracer here at the bottom, and then start your spans and give it some context. Like this is the get product list, as beginning of that span, and so on and so forth. Now, as you go through multiple methods, right, the span context will get passed from function to function, and each span will calculate the latency, collect the context, and all that information is passed back as events to the collector that we talked about earlier, and eventually back to the backend like Elastic. Now, the important thing here is that manually you can define what you want or don't want traced. So let's look at metrics for a second, right? In OpenTelemetry, unlike tracing, there is no automatic instrumentation capability in metrics, right? It is all manual right now, right? Also, it's not supported for all languages. Only a few are stable, and others are experimental, and even worse, some are not even implemented yet, right? Now, most people think about metrics, they think about host metrics, such as CPU and memory, etc. Well, that's not what OpenTelemetry metrics is about, right? This is about collecting application metrics, right? Not infrastructure metrics, right? And so for application metrics, you need to instrument your application, and you need to use something called an instrument, right? And in OpenTelemetry, there's several different instruments like counters, histograms, up-down counter, or gauges. And how you utilize this is that just like with traces, and this is again another version of the recommendation service, which is part of the OpenTelemetry demo. You import the metrics library from OpenTelemetry. You initialize your instrument that you want, and then You collect or increment that instrument. And in this case, we've instrumented a counter, and we're incrementing that counter when we make a specific recommendation, right? Now, there are multiple instruments, as I mentioned, and there could be more. And as more capabilities are added into the libraries and options, they will be available. So check out OpenTelemetry.io for the latest. Finally, let's look at logging, all right? The third signal. Now, the interesting thing about logging with OpenTelemetry is that it has very limited support for logging. The libraries are pretty much an experimental or not even in existence. Now, this could be changed by the time you're looking at this, because within a few weeks of me taping this, it may actually have gone to GA, who knows. So the community is constantly building it out and is catching up. And so just go to the OpenTelemetry.io for the latest and play with what you think you can. Some of them may be a lot more stable. So let's talk a little bit about what Elastic supports. The main thing to remember about what Elastic supports is the fact that we collect OTLP protocol natively, right? And what that means is we will take the OpenTelemetry schema as is, no modifications, no agents needed, nothing, right? So whether you do instrumentation in your code and you point it directly at Elastic, or you use the OpenTelemetry collector and point it directly at Elastic, we will take the OpenTelemetry schema as is and ingest that and store that and let you operate and work with that in our APM functionality. And we'll show you that in a demo. Okay, so for the demo, we're going to be running the following environment. Obviously, the OpenTelemetry demo, fully instrumented with OpenTelemetry agents and SDKs on multiple languages. We're going to be running that on Google Kubernetes engine, and we're going to use the most common standard configuration, which is to use the OpenTelemetry collector. We'll be sending that in directly from the collector into Elastic Observability. And to be specific, we're going to be running that on Elastic Cloud, our SaaS service. So let's get into the demo. Now, before we get into the demo, the first thing we need to do is to go to cloud.elastic.co and register and get a login and actually log into Elastic Cloud. And then we'll walk through all the different parts of Elastic's APM capabilities. Now, before I even do that, one thing I do want to go and talk to you about is how easy it is to interconnect your OpenTelemetry collector to Elastic. Now, in your OpenTelemetry collector YAML file, generally you'll have a config map. And inside the config map, you'll define different exporters. And in particular, you'll define an exporter to Elastic. And there's only two things that are needed. One is the OTLP endpoint in the APM server in Elastic's APM server, and of course, the authorization headers. And that's it. Once that's there, restart your OpenTelemetry collector, and you will start seeing in Elastic a service map, right? Of course, make sure you're running your traffic generator for the OpenTelemetry demo. And what you will see is this. You see the front end, the checkout service, shipping, product catalog, all the different services up and running. Now, the one thing that Elastic does, in addition to giving you this service map, is that we actually give you contextual information, right? So if you look here between the product catalog or shipping service and front end, they're highlighted in red. And why is that important? Well, you get some detailed information around the average latency and throughput. But what you also get is Elastic's ML capabilities in the background, constantly looking at pattern analysis as to what's happened on the service and detecting for anomalies. In this case, it's detected some sort of an anomaly on the front end. And if you go into the details around it, we see that it's had a spike on a few records with respect to high latency. Now we can go and investigate that further with anomaly explorers and things like that. But let's do this, and let's go a little bit deeper into the cart service, right? Which is sort of the main stable of service on the OpenTelemetry demo itself. Now, as we dive down into the cart service from an overview perspective, you get average latency for the service, you get an idea of what's been happening over a time series, you get the average throughput. You'll take a look at some of the main transactions that are coming into the cart service, any related errors or even failed transactions. In addition, you'll also get the set of dependencies. Now in the cart service, which is a .NET service, we are connecting to Redis. Now, the interesting thing here is that we do see a significant impact with respect to the add item transaction. So let's dive a little bit deeper into that. And when we do, we see all the standard sort of metrics around the transaction. One of them being latency and throughput, average time spent in the span. We don't see any errors. And then when we come down to take a look at the trace itself, what we get is a trace distribution, and we see something interesting. In general, all the traces are within maybe about 10 milliseconds, but there's a few here within the 6 to 8 to 10 second range. And when we take a look at the trace down there coming from OpenTelemetry, pretty standard. We can also take a look at the logs, and as we mentioned before, we're doing contextual information. So we're bringing in log information, not just to metrics. And here you can see a little bit of information that's coming from the front end service and the cart service that is related to the traces here. Now, how do we actually understand why we're having this sort of deviation, this massive deviation in latencies? Well, we pre-built a couple of capabilities, automatic correlations, which will use the ML capabilities in Elastic's platform to do that correlation for you. So you don't have to run any models, you don't have to do anything except press the button and click. And what Elastic does is actually goes through and does pattern analysis and uses ML algorithms to kind of to take a look at logs, metrics, and it takes it across not just the application information, but it also takes it across the infrastructure information. Now, in this case, as I mentioned before, we're running Google on Google Cloud on GKE. So here it's brought up potential high correlation items. Kubernetes issues, potentially, but the most interesting one is the fact that this is on a service version number of 1.7. Now that could kind of tell us that, hey, are we running a different version than what was deployed maybe an hour ago or 2 hours ago? We can see if there's any differential. So what it's done is given us a place to look, whether it's on the infrastructure or service versions. There's a couple of different ideas of where and why we're having this high latency and from a correlation perspective. Now, that was a quick review of some of the capabilities in Elastic's APM service with respect to OpenTelemetry. And as you see, we support any and all the same capabilities we had with the APM agents from Elastic with OpenTelemetry. So hopefully you enjoyed the demo. Okay, so what did we learn in the demo? Well, and in this presentation, right? So there's three things hopefully you saw, right? One is that Elastic provides native OpenTelemetry support. We collect metrics, logs, and traces from your application. Secondly, right, any and all the existing APM capabilities that we originally supported with Elastic agents are now completely supported, no modifications, no changes for OpenTelemetry-based telemetry signals, right? Whether it's service maps, latencies, dependencies, transactions, and you saw that in the demo. And finally, hopefully you saw that we have contextualized unified views, which add in capabilities like correlations for errors, correlations for latency, and an ability to go and do anomaly detection and find outliers and do some predictive capabilities and modeling. So are you interested? Well, go to OpenTelemetry.io, go to the GitHub site where OpenTelemetry is, take that down, load that someplace, sign up for an Elastic Cloud account, and connect up your OpenTelemetry demo to our APM endpoint and start playing. So hopefully we see you on Elastic Cloud. Thank you.